Assalamu alaikum. Hello everyone. My name is Aya Alim Saadin. I am going to present my paper. The title is Preliminary Strength Characterization of Peat Soil Stabilized with Rich Gypsum Waste. This is the outline of the presentation. Peat soil is a problematic soil has typical characteristics including high natural moisture content, uh, high compressibility, low bearing capacity. These weak geotechnical properties result in avoidance of many construction works. Hence, an improvement method is needed, like the soil stabilization technique, to increase its stability by improving its weak properties. In recent years, sustainable approach in stabilizing the soil in an environmentally friendly way is recommended. This research examined the feasibility of chemically stabilizing peat using recycled rich gypsum (MRSG), which is waste from industries, to improve the characteristics of peat soil as a part of sustainable soil stabilization in civil geotechnical engineering to eliminate excessive amount of waste and support innovation for a sustainable future. Methodology of this paper. We started with collection the peat soil and MRSG samples. After collection, we prepared the peat soil and MRSG separately by drying, then saving. And before preparation the mixture, we mixed the peat soil alone by hand mixing method for obtaining a homogeneous condition. Then we started to prepare the treated sample by dry mixing between peat and MRSG in different percentages, range between 0 to 20% of the dried weight of soil. After the treated sample were prepared, we started the characterization of peat soil with MRSG. Characterization of peat soil and rich gypsum. We started with a preliminary study on the strength improvement by unconfined chromosomal strength UCS test. The peat soil with MRSG were characterized using pH test, scanning electron microscopy, SEM-ELEX, transform infrared spectroscopy, FTIR. Results and discussion. Classification of peat soil. The peat soil was classified based on the result of pH and organic content. As shown in the table, the peat soil, based on the result of pH, was classified as very acidic and as high ash peat based on the organic content test. pH analysis. The MRSG, which has pH of 9.47, making it extremely alkaline, caused an increase in pH of the peat when it was combined. As shown in the table, the pH for peat without MRSG is 3.54, but it increased up to 5.93 with a 20% content of MRSG. Confined compressive strength. From the figure, it was observed that the treating with MRSG improves the strength of peat. The strength value climbed from 15.45 kilopascal at 0% MRSG to 59.15 kilopascal at 5% MRSG added into the soil. The strength improvement is obtained for the 5% MRSG content and 26.1% gain in strength was observed. However, this value decreases to the 31 kilopascal when the MRSG content added to the peat was 20%. SIM. The figure shows the scanned electron microscopy for MRSG. MRSG has crystal and elongated shape with multiple interconnected spaces. This crystal shape allowing to fill the porous microtouch surfaces of the peat structure. These are the microstructures of untreated and treated peat under same magnification condition. We can see the untreated particles have a fragmented structure that contains visible voids and pores, whereas The treated particles have small pores due to interaction between peat and MRSG, case, reorganization, and increase in interparticle force. Index. The table shows the mass percent of some elements in MRSG, untreated soil, and treated soil with 5% MRSG. The MRSG is rich of Mg. Mg can contribute to the stabilization of peat, while MgO hydration is an expensive reaction that can increase solid volume and filling the pore between treated and untreated peat. The treated peat had an increase of Si, Al, Ol, O elements. It's important to stress that these elements are essential for the formation of CSH and CAH crystals, which are the main cementation products in the treated soil. FCIR. It was discovered that the mixture has possibly more functional oxygenated groups on it, which caused some changes in the absorption bands, frequencies, and intensity. Conclusion. In this research, a preliminary analytic approach using MRSG for the stabilization of peat soil was carried out. MRSG has been proven as sustainable material that has the potential to stabilize peat soil by increasing the strength of the peat and developing the microstructure of treated soil. Future research is recommended to treat peat soil using MRSG with the effect of curing time. References. Thank you for your attention.